Yes, hello everyone. In this session, we'll study about what is hydraulic turbine, or also we can refer it as water turbine. So basically, what is a turbine? So a turbine is a mechanical device which converts mechanical energy into electrical energy by means of what? See, first the water will be stored somewhere that will be having some potential energy, and that potential energy of water is converted to kinetic energy of water when we make that water to flow. Okay, when that flowing water hits some turbine, the turbine starts rotating. Okay, that means there is a conversion of kinetic energy of water into mechanical energy of turbine. Fine. Once the turbine rotates, it is been coupled with a rotor. Once the turbine rotates, even the rotor rotates, so there is a production of electricity. So that means mechanical energy is then converted to electrical energy. So basically the function of a turbine is to convert mechanical energy into electrical energy by means of this. Fine. So now there are some types of turbines for your syllabus in particular. So the first one is based on energy available at the inlet of the turbine. So there are two types based on this category. The one is impulse turbine and the other is reaction turbine. So what is impulse turbine? Like for example, if I slap you, that is the impulse, that is the force exerting by me on you. So that force is responsible for the flow. So if the water hits the blades of a turbine, the turbine rotates. That is the impulse force. As simple as it is. Okay. And the next is reaction turbine. What do you mean by this? This means, see for example, if I slap you, you will slap me back. So that reaction from you is responsible. So that means both the impulse force exerted by me as well the reaction from you, both are responsible for the rotation of the turbine. That I'll explain while explaining the turbine. So that is what reaction turbine is. Okay, this is based on the first category. Coming to the second category, it is based on the head under which the turbine works. So there are three types: high head turbine, medium head turbine and low head turbine. So that means the amount of height with which the water falls. Like for example, what happens if you jump from first floor to the ground floor, and what is the difference you can make out if you jump from fifth floor to the ground floor? There is a difference in impact, right? So that we will study while studying the particular turbines. Okay, third category is based on the direction of flow of water through runner. As you know, there are so many principles of flow. For example, tangential flow, axial flow, a radial flow, or mixed flow. It may be a mixture of axial as well radial. That these things I'll explain while explaining the particular turbine part. Okay, so this is about the basics of hydraulic turbine and the types. Hope you understood this. So there are basically three important types of turbines for your syllabus. One is PELTON wheel turbine, another is Kaplan turbine, and the last one is Francis turbine. So in this video, we will study about PELTON wheel turbine. So as we discussed in the types of turbines, there are three categories. In that, there is impulse reaction, high head, medium head, low head, and tangential, axial, radial, mixed flow. So we have to categorize this PELTON wheel turbine based on those three categories. So this PELTON wheel turbine comes under impulse flow, high head, and tangential flow. That means that slapping mechanism, So the direct hitting of water to the blade is sufficient enough for the rotation of turbine. So that is impulse. And high head, that means the water has to fall from higher heights so that the turbine rotates. And the next is tangential flow. That means the direction of flow of water on the turbine blade is tangential. So the Pelton wheel comes under impulse flow, high head and tangential flow. Fine. So coming to the construction of this, as you can see here, there is a runner, which the main function of a runner is to rotate, okay, and the runner has got some buckets or vanes, those are the blades of the turbines, and which is been included in the casing, outer casing for production. And here as you can observe, there is a nozzle from which water comes and which hits the blades of the turbine. So there is a hand wheel. Using this hand wheel, we can control the flow of water to the turbines, okay, and this is the water in here the water starts flowing, okay, and there is a tail race. That means the water which is being used will flow through this tail race, and it can be used for so many agricultural purposes. So that is what about the construction. So what happens now? The water enters the nozzle, okay. What is the function of a nozzle? The function of a nozzle is to the exact function of a nozzle is to give particular direction to the water, and it will increase the velocity of the water. So it will increase the velocity, so the high velocity water hits the blades of the turbine. Once the high velocity of water hits the blades of turbine, the turbine starts rotating. When the turbine rotates, what happens? The kinetic energy of water is being converted to mechanical energy, right? Once this turbine rotates, this turbine is being coupled with rotor. Once this turbine rotates, even the rotor rotates. So there is a production of electricity. So that means the mechanical energy of turbine is converted into electrical energy. See, as you can observe, this is the shaft. This is the common shaft for this turbine as well rotor. So once this turbine rotates, even the rotor rotates. So the mechanical energy is converted into electrical energy, and that is how we are going to produce electricity using this Pelton wheel turbine. Understood? So this is how the Pelton wheel turbine works, which is basically impulse flow, high head, tangential flow turbine. As you can observe here, this is the zoomed view of buckets or the blades of the turbine, which is usually of hemispherical shape, and this is the nozzle from which the water hits. Once the water hits, the turbine rotates, and the water being used will be exited like this, and the function or the cycle repeats, right? So this is one of the types of hydraulic turbine. Since water is responsible for the rotation of the turbine, it is called hydraulic turbine. Thank you.